Right, in section 7.3, page 92, we introduced to three different types of graphs. Excuse me, line graphs, frequency polygons, and histograms. Again, we work out to grade C maximum, and instead of me doing a question and plotting a very simple line graph, what we see there on screen is a line graph, and it's been ready plotted. I merely sort of extracted it from the textbook and shoved it on this video. Very straightforward. What we have is a series of time from 10 o'clock to 2 in the afternoon, and we look at the temperature of a patient at these times of the day. So at 10 o'clock the temperature of the patient was 102.5 degrees Fahrenheit. An hour later at 11 o'clock 101.3, got a bit of a drop there. At midday 102, etc. And the data is plotted on a line graph as shown. That's the time of day along the x-axis and the temperature along the y-axis there. So this is what the patient's been doing, and that's all you have to do. Just plot the points as regular coordinates, join them from cross to cross to get this jagged effect, and that's it really. There are certain assumptions that you make when doing such a graph. So for example, you're assuming that from 10 o'clock to 11 o'clock there was a steady decline in the patient's temperature. This may not have been the case. There could have been, for example, a high point there. At 10:30 in the morning, the patient could have had a temperature of 102, and then perhaps drop down to 101.3 at 11 o'clock. So because there are no times between the data and the points shown, certain assumptions are made. Now the general trend is downwards, obviously, and then the patient's temperature levels off. But for example, look at this drop here between 12 and 1 o'clock, 1300 hours. There's a very sharp drop. So the patient could have done this, supposing the temperature was taken at, I don't know, 12:30. Could have been there. We could be looking at something like this, and then a very sharp drop down to 1 o'clock. It depends. All right. So this tells a very broad story. But there's other things happening between the times, and we've assumed there's nothing else of significance happening there. Right, turning over to the next page. Right, I've already prepped my grids for this, and so what I've got here is a table that's showing the time spent in a local shop by 60 customers. So I know the total is 60, so I'll just underline that, so that's going to be significant later, I'm sure. So this is sort of 60. 5 to 10 minutes, 10 to 15, but as before with group data, you're allowed to be 5 but just be under 10. You start off from 10 but be under 15. You start off at 15 but be under 20, etc. Alright? And I've got to draw one type of frequency diagram. Well, I want to do a histogram first, and as you can see, these classes have equal widths, they have equal intervals, and therefore I'm going to do a straightforward histogram as follows. Let's see if I can get the software to work. Right, one of those called up red, so why not? Right, we've got from 5 to 10 a frequency of 8. It's quite hard to draw this actually. 8's going to be about there. Let's have a look. 5, 6, 7, 8. Yes, it's about there. If you look very carefully, from 0 to 5 you've got 10 squares, therefore 1 unit counts for, 2 squares take up 1 unit. So frequency of 5 is 10 squares. Alright, that's that one. Now I've got to try and then make the next one touch if I possibly can. So, I should have started from the bottom, shouldn't I? So let's start from there, go across, go all the way up to 30. Yep, I'm happy with that, it's good. Next one's going to be up to 16. So take it across here. Go up to 16 if I can, 15, so 2 squares makes 16. Okay, that's as best I can do at the moment with this. There you go, leave that there. The next one, 20 to 25, goes as far as 6, so let's see if I can do that. That's exactly 5, 1, 2 squares, 6, okay. That should have been, let's have a get back to pen. That little bit there should have been a little bit thinner, it's quite hard to control the pen. But anyway, that's a histogram, and I'll call it that. And it's got equal bar widths Alright? Okay, learn to do my D's properly. That's fine. And I've now got to draw a different type of frequency diagram, hence the label frequency there and there. Now, the next one I want to do is a frequency polygon. Now, with frequency polygons, we look at the midpoint of each class and we plot that. So between 5 and 10, we have 7.5. Between 10 and 15, 12.5, etc., etc. So our first point will start from 7.5, and we're going to go up to 8. So 8 is there, from what I can see. Next one, 12.5 and 30 up. So that's between 10 and 15. 30 up is quite easy to spot. It's right there. Next one, 16 along, 16 up, sorry, between 15 and 20, 17.5, 15, 16, I'm planting it right there. And finally 20 to 25, we're going 22.5, 22.5 between these two intervals. What are these called? These two bounds rather, not intervals, is 6. So I'm going to put that there. Now my job is to try and cleverly join them with a line. So start there, okay, dot to dot, start here, lift off the pen, put it down, and that is the frequency polygon. I'm really happy with that, and that's called a frequency polygon. Very happy for a first time. Now look, if you look at the comparison, it's as though we've taken this histogram and put a little coordinate between the bars, right in the middle of each bar, and I could, if I wanted to, let's go for blue to make a different issue with it, I could in fact join it from there to there, and from there to there, and from there to there, and I've got exactly the same frequency polygon as I have on this side over here. Alright, so we can now see the relationship between a histogram on this side with a frequency polygon on this side. So to revise then, a histogram, all the bars touch because we have time as being a continuous variable. There's no artificial gap between time. So that's what we do. The bars touch, and we just draw them as a bar chart, so to speak, although it's called a histogram. And for a frequency polygon, on the right hand side over here, we can see that we just use the midpoints of each class width, and then we take the frequency up as high as it needs to go. In the first case it was 7.5 along, that's the midpoint, and 8 up. And we have two different frequency diagrams, and I'm very happy with that. Let's see what the next question's about. Okay, lovely. I've got a ready-made frequency diagram. Let's take a look at it. The frequency diagram, they haven't told us it's a histogram, but it is in fact. The frequency diagram shows the ages of 81 people. That could be significant. Let's put 81 over here. I could use that later. In fact, let's put it over here. It shows that better. I might need that. Draw a frequency polygon. Well, I'm not going to do that. I'll tell you why I'm not going to do that. It means doing another grid. But what I will do is take the midpoint of 20 and 30 and call it 25 and plot it directly on their one. And look, I know the frequency is 25. I'm just going to come along and do that. Between 30 and 40, the frequency is 30. I'm going to do that. Between 40 and 50, the frequency is, what's that? 15, 16 and 17. Put it right in the middle. And finally 50 to 60, midpoint's 55 along, and it's on 9. Now let's just go to straight lines, and I'm going to try and get these to join. It's in blue because you remembered it from last time, and then that one to that one, and that is my frequency polygon drawn using their own grid. So there you go, and that again clearly illustrates the relationship between a histogram and the frequency polygon that you can produce directly on top of it. Again, in exams you probably won't be asked to do two, you do one or the other, and probably you won't get one superimposed on top of the other like that, but it can be done. Right, part B, draw a frequency polygon. I've done it. What I didn't do is part A, so I'm going to do that right now. It says I've got to copy and complete the information. Well, alright, I'm missing the frequencies. The frequency for the first one is 25, I'll put it there. The second one is 30, I know I mentioned these before when I did the frequency polygon. 40 to 50 bar goes up to 17, and 50 to 60 is 9. With a bit of luck, that should add up to 81, 50, 60, 69, 76 plus 5, 81. So I've got that completely correct. Tick for you and a tick for you. Right, what fraction of the people in the factory were under 40? Under 40, well look, 20s to 30s, 30s to 40s, but if you look very carefully, that says less than 40. Therefore, these 30 and these 25 were under 40. Just hit the yellow again. So I'm now going to do part C, what fraction of the people in the factory were under 40. I've got 55 over 81, and I don't think that can be simplified. Okay, I know I've got 81, it says so over there, and we're going to do part D over here now. Of the people under 40, in other words, I've got 55 people who are under 40, and of these people here, it says what percentage are under 30. Well, that's this little group here, as you can see. Look, the 20 to under 30s. Therefore, I've got 25 of those, and this one I can simplify. I'm going to simplify it down using 5s. So that's going to be 5 over 11. Just dividing top and bottom by 5 as usual. And on this side, I would actually want to convert it into a percentage to answer the question fully. So 5 over 11 times 100. Grab my machine, and we'll get an answer. Switching it on, 5 divided by 11, multiplied by 100, that gives us 45.45454545. So I'm going to round it off to one decimal place. 45.5% of the people who are under 40 were also under 30. Okay, so that's the end of that. We've done a histogram, so that thing there. We've done a little frequency polygon, that thing there. If I go back a couple of pages, we've done also a line graph. Alright, so let's just write it down. Line graph. Alright, so that's it. Another quick review. Obviously you can go backwards and forwards with the video at will. So line graph, frequency polygon, histogram, and there's a relationship there between the histogram and the frequency polygon. And here's a question relating to frequency polygons and histograms, and came straight out of the book. Alright, so enjoy that, have fun.